Lake Mead still looks alive. The water is still blue. Boats still move across the surface. But the 18-story white stain ringing the canyon walls is already telling you the system is failing. That calcium carbonate band sits 180 feet above the current waterline, and it is the visible mineral record of what was extracted and never replaced. What looks like a functioning reservoir is really a gravity-fed bathtub draining toward a threshold where the water physically cannot move anymore, and the losses spread from there. Lake Mead is not healthy anymore. Some people see it as a drought problem. Other people see it as a political problem. But I see something more structural. I see a reservoir built on accounting fiction, locked into a fatal design flaw, and approaching a hard threshold where 25 million people lose their water supply, not because the lake is empty, but because the dam cannot move what remains. But through a forensic lens, Lake Mead is not just low. It is a gravity-dependent infrastructure system racing toward the elevation where gravity stops working. To understand the horror of the Lake Mead model, we have to look at the paper water compact that created the crisis in the first place. In 1922, 7 states signed the Colorado River Compact and divided 17.5 million acre-feet of water per year among themselves. That number was not conservative. It was not a drought hedge. It was based on stream flow measurements taken during one of the wettest periods in 500 years. Tree ring data now reveals the early 20th century was a historical fluke, and the negotiators mistook abundance for normal. The actual river has averaged closer to 13 million acre-feet per year since 2000. That gap is over 4 million acre-feet annually. In simpler terms, the legal system promised 1.3 trillion gallons more water every year than the river actually carries. Every year, the accounting fiction grows. Every year, the water level drops. And every year, the reservoir moves closer to 895 feet, the Deadpool elevation where Hoover Dam's intake pipes sit above the waterline, and the supply for Nevada, Arizona, and California simply stops moving. Look at it. The white bathtub ring is not a stain. It is a measuring stick. It shows you exactly how much water was promised, used, and never refilled. The system is not experiencing a temporary drought. It is experiencing a permanent structural mismatch between legal rights and hydrological reality, and the deficit is visible on the canyon walls. Now look at a Hoover Dam intake tower. The dam has 4 intake structures built into the canyon face, and each one draws water at a specific elevation. The lowest intake sits at 895 feet above sea level. Below that line, millions of acre-feet of water remain in the lake, but it is dead storage. The dam has no pumps. It relies entirely on gravity to push water through its pipes and into the aqueducts that feed Los Angeles, Phoenix, and Las Vegas. If the lake drops below 895 feet, the water is still there. It is just physically trapped. The dam cannot reach it, the cities cannot drink it, and the system stops. This is not a theoretical risk. Lake Mead is currently hovering near 1,040 feet. It has dropped over 170 feet since 2000. The distance between the current waterline and Deadpool is 145 feet. That is not a comfortable margin. That is 15 years of average decline, and the decline is not slowing. It is accelerating. But the deeper problem is that the system fails long before Deadpool. At 950 feet, the dam's power turbines must shut down to prevent mechanical damage. The turbines are designed to spin under a specific range of water pressure. Below 950 feet, the pressure drops so low that air bubbles form in the flow, a process called cavitation that physically pits and destroys the metal blades. To protect the equipment, the dam stops generating electricity. That cutoff happens at 950 feet. Deadpool happens at 895 feet. The difference is 55 vertical feet. For context, that is the height of a 5-story building. In that 55-foot zone, Hoover Dam becomes a dam that still moves water but no longer generates power. 1.3 million people lose electricity. Hospitals, air conditioning systems, and water treatment plants that depend on Hoover Dam's grid lose their primary power source, and the system has not even hit Deadpool yet. The power failure is the early warning. The water failure is the final threshold. And the 55-foot gap between them is closing. This creates a reinforcing failure loop. As the lake drops, evaporation becomes more efficient. The desert sun bakes 600,000 acre-feet of water off the surface every year. That is double the entire legal water share of Nevada. Lower water levels mean hotter surface temperatures. Hotter surfaces mean faster evaporation. Faster evaporation means lower water levels. The system is eating itself. And every foot of elevation lost makes the next foot harder to recover. Now look at the infrastructure that depends on Lake Mead staying above Deadpool. The Central Arizona Project is a 336-mile concrete canal that moves water from the Colorado River to Phoenix and Tucson. It cost $4 billion to build. It supplies 40% of Arizona's water, and it depends entirely on Hoover Dam releases. If Lake Mead hits Deadpool, the canal goes dry. Arizona has junior water rights under the law of the river, meaning it is the first state to face cutoffs during a shortage. If the lake cannot release water, Arizona does not get to pump from a backup source. It just loses the supply. $4 billion of infrastructure becomes a dry ditch. 2.4 million people in the Phoenix metro area lose their primary water source. And there is no immediate alternative. The same pattern repeats in California. The Imperial Valley produces the majority of the United States' winter vegetable supply. It is America's winter salad bowl, and it is irrigated entirely by Colorado River water delivered through the All-American Canal. If Hoover Dam stops releasing, the canal stops flowing. The farms go dry, the food supply tightens, and the economic losses cascade. Economists estimate a total failure of the Hoover Dam system would trigger a $1.4 trillion crisis across the Southwest. That is not speculation. That is the value of the infrastructure, agriculture, and urban systems that depend on Lake Mead staying above 895 feet. But the most advanced part of the problem is not the visible bathtub ring or the dropping water line. It is the calm surface of the lake itself. To most people, Lake Mead still looks functional. The water is blue, the shoreline is visible, the boats are still moving. And that apparent normalcy is what hides the deeper failure. Because Lake Mead is not a natural lake. It is a reservoir. It exists to store water, regulate flow, and deliver supply on demand. A reservoir that cannot deliver is not a low reservoir. It is a failed reservoir. And the failure does not wait until the lake is empty. It happens the moment the water drops below the intake pipes. At that point, the lake could still hold 2 million acre-feet of water. It could still look alive from the shore. But if the water is below 895 feet, it is dead storage. It is water that exists, but cannot be used. And the system is already moving toward that threshold. You, the viewer, should watch the elevation number next. Not the news stories about drought, not the political negotiations. Watch the lake elevation. 950 feet is the power cutoff. 895 feet is Deadpool. The current level is around 1,040 feet. Every foot of decline is 1 foot closer to the threshold where the system stops working. And every foot of decline is harder to reverse than the last. If the inflow held, this failure loop would ease. If the snowpack returned to 20th century levels, the reservoir would stabilize. But the river is not recovering. The 1922 compact promised 17.5 million acre-feet based on wet era measurements. The actual river is delivering 13 million. The deficit is structural, and the accounting fiction is written into federal law. The system is not designed to handle the reality it is facing. It is designed to handle the reality it was promised. And those two things are no longer the same. Finally, we have to look at the one city that saw this coming and built an escape route. Las Vegas spent $1.5 billion constructing a third intake straw and a deep pumping station at 860 feet. That is 35 feet below Deadpool. If Lake Mead drops to 895 feet, California and Arizona lose their water. But Las Vegas can still pump. The third straw allows the city to drink even when the dam cannot release. It is a unilateral survival strategy. It does not solve the regional crisis. It just allows one city to outlast the others. And the fact that Las Vegas felt the need to build it tells you everything about how seriously the city takes the Deadpool threat. This is not a problem that can be solved by conservation alone. 80% of the river's water goes to agriculture, much of it to grow alfalfa for cattle feed. Residential users in Los Angeles and Phoenix are not the primary consumers. The farms are. And the farms operate under legal water rights that predate the cities. Cutting urban use helps, but it does not close a 4 million acre-foot annual gap. The system is not failing because people are wasteful. It is failing because the legal framework promised more water than the river can supply, and the infrastructure was built to depend on that promise being kept. Lake Mead is not dead yet, but that is the point. The crisis is not in a dry lake bed. The crisis is in a reservoir that still looks alive and no longer functions as designed. The bathtub ring is not the collapse. It is the symptom of the collapse. The real failure is in the 55-foot zone between losing power and losing water, in the legal fiction that divides 17.5 million acre-feet of a 13 million acre-foot river, and in the gravity-fed design that turns a reservoir into a trap the moment the water drops below the intake pipes. Now you know what to watch the next time you see Lake Mead, and why it matters. Thanks for watching. I appreciate you. If this breakdown helped you see the system more clearly, consider subscribing. Tell me which water body to cover next in the comments. The next case file is already in progress.